Good evening, ladies and gentlemen, and welcome to Tech Talk organized by NUS Alumni Relations. We will be starting shortly. In the meantime, please do note the following. For security and personal data protection purposes, participants' video and audios will be disabled. Please post any questions you may have in the Q&A window. Your questions will be reviewed by the moderator and may be grouped with similar questions to be answered. If you require any technical assistance, please message the administrator via the chat function. The session is being recorded and will be made available on NUS Alumni Relations website after next week. NUS Alumni Relations and its event partners may use some or all of these images and videos in its publications, digital platforms, and/or marketing channels. This evening, we are pleased to have with us two speakers from the Institute of Systems Science, NUS. First of which is Dr. Nicholas Ho, lecturer and consultant, Artificial Intelligence Practice, and Mr. Ng Kok Leong, senior lecturer and consultant, Digital Strategy and Leadership Practice, to share their insights on the topic IoT and 5G security for the future. So without further ado, I would like to pass the time over to Dr. Ho and Mr. Ng.
Hi, very good evening. My name is Kok Leong. If we were to Google IoT and 5G security, the discussion are usually about enterprise security issues such as patching. Security requirements, they are very basic to enterprise, as simple as patching, are not so straightforward in the perspective of smart things. I will discuss the constraint behavior and solutions of things. Before that, my colleague Dr. Nicholas will introduce IoT and the use cases in the context of 5G. Dr. Nicholas.
Thank you, Kok Leong. Okay, so right now I'm going to start off by introducing about IoT and 5G. But before I do that, allow me to introduce myself. I am Nicholas. Okay, you can call me Nick. I'm like Kok Leong. I'm a lecturer at NUS ISS, and courses that I teach includes mainly IoT and robotics-based courses. And like most of you guys, I graduated from NUS, in particular the School of Engineering. Okay, so this is the introduction contents of today. Initially, I want to introduce what is IoT. So basically, IoT stands for Internet of Things. I believe most of you are already aware of what is the Internet. Okay, and Internet, right? Like what are you using now? It connects all people. So be it through your social media, be it WhatsApp, or be it Instagram, Facebook, and even right now you're using the Zoom. Okay, right now this is what we call the internet, right? It connects people through our devices, right? And IoT is just an extension of the internet, which helps to connect all things. Okay, I believe most of you have been wondering what is this thing is about. Okay, so thing is just a representation of smart devices, so such as your smartphones or even your laptops, the ones you're using now, or it can be even devices around your house like the smart printers or even smart weighing scales. Okay, so two criteria that constitute a thing, or rather a smart device. Number one, it is able to connect to the internet. Number two, it is able to have minimal computer processing. Okay, so end of the day, remember the key elements of IoT. Number one, connect, right? So your smart devices have connectivity to the internet. Number two, process, be it data collection, data analysis or management, and of course, making sense of data. This constitute under the key element of process. And lastly, the last key element of IoT is act, right? So such example is to have automated or autonomous tasks being executed by the system. So for example, let's say we have an Apple Watch, okay, and in response to your BP or maybe your heart rate, okay, it prompts you to go to the hospital because of perhaps maybe some critical or some urgent matters to be that you have to attend to. Okay, to start off, let me first introduce the concept of some of the wireless technologies. Some of it you are pretty aware of or pretty very familiar with. So some of it is such as a Wi-Fi or Bluetooth, which what we are using now to connect to the internet. And of course, Bluetooth, which we connect some of our smart devices, such as the smartwatches. And of course, we are also familiar with some of the cellular networks, such as 3G and 4G, and even LTE networks. Okay, but I think what some of us over here that are not very familiar is this category, which is called the LPWAN. Okay, so LPWAN stands for low power WAN. Essentially, as compared to the Wi-Fi and Bluetooth, it has a higher range, right? Of course, that comes with a price of lower data rate. Okay, so this LPWAN is very useful for applications that does not require high data usage, but long range. Okay, so zooming into LPWAN, there are two categories. Number one, licensed LPWAN. Right, in Singapore, NB-IoT is very popular, and you have to register with the providers such as Singtel or StarHub in order to use such technology. On the other hand, we have the unlicensed LPWAN. LoRa and Sigfox are the popular ones in Singapore. Right, with this, it does not mean that you do not have to pay. You still have to pay. Okay, but of course, you do not need to register with the provider. So following which, I'd like to just share some of the value add that IoT systems can bring to you as a user. Okay, so the main important value add that IoT can bring to you is this thing called the offsite functionalities. And what I mean by offsite is that, right, you do not need to be physically near the IoT system in order to do offsite tasks such as monitoring, control, or even receiving alert from the system. Okay, so this is the first main value add that IoT system can bring to you. The second main value add that IoT can bring to you is what we call, right, collecting data for you, and also to process and monitor, and also to store and manage data. Usually this comes, right, coupled with the cloud platforms, which help you to execute all these tasks. Okay, so let me give you, or rather showcase a case study based on a real product called Tado Smart Thermostat. So this Tado Smart Thermostat product, it looks like this IoT device over here, or rather a smart device over here. Okay, and what it aims to do is to replace the traditional remote control that allows us to control the air conditioner. Okay, so with this little device over here and more aesthetic looking, okay, we are able to reduce some of the buttons that we do not use regularly. Okay, so if you look at your traditional remote control right now, you notice that you every day you only use several buttons. Okay, so such as on and off, or rather to increase or adjust the fan speed, or to adjust the temperature, right? So these are some of the features that you use regularly, which is placed in this smart little device over here. So I think some of you must be wondering, what if I want to configure the other features? Okay, so that is where IoT can give value to such a problem, right? You can throw the rest of features into a mobile application, or rather a backend, where you can fully configure the other features, right, within such an application. Okay, so in summary, what IoT system can do for you is to reduce the complexity of the front-end device or the front-end user interface, right? Reduce the amount of buttons, make it more aesthetic, and throw the rest of the features that you wish to configure in the application. So moving ahead, let me share some of the aspects of IoT. Of course, IoT is very broad, and in the interest of time, we do not have time to cover every aspect of IoT. Okay, but of course, let me just share some of the interesting ones and of course, those that we use in our everyday lives, especially in Singapore context. Okay, so the first one is this thing called the voice user interface, or VUI for short. Okay, so what VUI can do for us, it can help us to command systems through just our voice, right? So as to initiate automated services, right, or automated tasks. Okay, so these are some of the examples of VUI platforms. Okay, for those who are using Apple phones, right, you'll be very familiar with the Apple Siri, and you're able to give command to the Apple Siri to execute tasks for you, right? So let's take for example, I want Siri to help me find the meaning of a word. Okay, so I can it goes like this. I can say, "Hey Siri, right? What's the meaning of this word?" And of course, Siri will receive my command through voice, okay, and will search through the internet, okay, and respond in a manner such as, "Hey Nicholas, the meaning of this word is so and so." Okay, so this is just a good example, but of course, I have a better example through a video. Okay, so from this video, it's kind of funny video, all right, but of course, there is serious message behind it. And while you enjoy this video, please try to catch some of the cues, right? What are the advantages and disadvantages of this VUI technology?
Playing jazz.
Playing jazz.
Smoothie.
Making smoothie.
Calendar.
No meetings today. Remember, tandläkare at 9:30.
Fire off.
Fire off.
Open door.
Door open.
Sånn, så skal vi sette en til.
Ah, ja. Open door.
Wrong voice command.
Open door.
Wrong voice command.
Open. Open door.
Repeat that.
Open door.
I didn't understand that.
Hey, open door.
Play on the floor.
Sick on the floor.
Get on the floor. Open the door.
Wrong voice command. Error.
Hey, Ura. Open door. Open door. Open door. Fire.
Higher volume.
Fire.
Higher.
Okay, so I hope you enjoyed that video. Of course, even though it's a comedy, okay, of course it has very serious message behind it regarding this voice user interface. Okay, so I'm not going to go through all the advantages and disadvantages. Of course, I'll just go through the main ones. So as advantage of voice user interface, the VUI, okay, as you observe, when the man goes down the stairs, right, just by using his voice, he's able to command the system to do certain tasks for him. So for example, when he walk downstairs, he say smoothie, and the system make a smoothie for him. And when he wants to go out of the house, he just say open door, and the system just open the door for him without even physically touching any controls. Okay, just by his voice alone. But of course, if you look at the disadvantage, it is evident that in the event, if the user has his voice impaired, it is unable to effectively control the system, right? So let's look at the other aspect of IoT, which what we call the IoT wearables. Okay, essentially what is IoT wearables? They are smart devices that are worn by humans. Of course, under this field, there's many categories. Okay, so the most famous or rather popular category in Singapore is the smartwatch. Okay, so be it your Fitbit or Apple Watch or the smart tracker that's given by the government a few years ago. Okay, so this constitute under the category of the smartwatch. Of course, there are many other categories such as smart glasses. Okay, this one example is like the Google Glass, and of course, smart shoes. Right, one example is the Under Armour Gemini. Okay, so all these devices, in a way, they help you to track information. So, for example, like smartwatch, right, like Apple Watch and Fitbit, it helps you to track your health and fitness status. Okay, so all these IoT wearables, they also contain small sensors that help you to collect data. Okay, and all this data, most of the time, all this data will be sent to an edge computer, usually in the form of a smartphone or laptop. And from there, the edge will send the data to the cloud for further processing, such as maybe data analytics, right, or data management. Okay, so these are some visual illustrations of popular IoT wearables. Okay, of course, the one on the left, these are more popular in Singapore, right? The top left over here, this is called the Fitbit, right? Bottom left, I think most of you may have this, or maybe your friends have this, or family have this. Okay, this is called the Apple Watch. Okay, so it helps you to track, for example, like the number of steps you did per day, or the number of distance you have walked or run per day. Okay, so these are some of the popular examples. The one on the right, not so popular in Singapore. Okay, so for example, the top right, we have the Google Glass. Okay, what the Google Glass do for you is to overlay the augmented reality display over the prism in the Google Glass over here. Okay, and of course, it has a camera and it has a CPU and battery being placed at the side of the glass. Okay, however, this product has been already phased out due to its limitations, right? Because of its battery, it's not able to last that long, as well as its CPU is not good enough for its functionalities. And the last product over here, okay, this is known as the Under Armour Gemini. Okay, it looks like, I mean, of course, on the surface, it looks like a normal shoe. Okay, but don't be fooled. If you actually dive into the sole over here, okay, you can actually find initial motion sensors, IMU sensor for short, okay, which help you track your motions. And you'll also be able to find connectivity equipment that allows the shoe to connect to the smartphone, right, and hence connect to the internet. Okay, so that's all for wearables. Right, in a nutshell, I think most of you are aware that IoT is getting more matured. However, there's still much room for improvements. Okay, so take for example in the medical industry. Okay, let's say in the hospitals we can have all the patients having worn like the IoT wearables for short. For example, okay, and with that we are able to efficiently and effectively track every patient's health status, right? Hence able to even potentially decrease the cost, right, of hospital stays. On the other hand, if you look at the retail sector, okay, much room for improvement as well as the shopping malls or maybe the individual shops can implement IoT systems to, for example, to monitor the shoppers' patterns, okay, and this could possibly translate to profits for the retail business. But of course, the highlight for today, which what we want to zoom into, is the vehicle industry, in particular, autonomous vehicles. Okay, so next I'd like to share with you, or rather discuss with you, okay, what are the possible IoT involvement in autonomous vehicles. Okay, and before I do that, I'd like to showcase one example of a current autonomous system, or AV for short, right? AV system for short. Okay, so just a synopsis, this example is also known as the Waymo self-driving car. Okay, and Waymo, for your information, right? It used to be called the Google self-driving car. That was before it rebranded itself into Waymo. Okay, but of course, while you enjoy the self-driving experience, please just remember to fall back on the main topic and think about how IoT can be relevant in such system, right? And also think about whether IoT is crucial in the autonomous driving over here, right? So please enjoy the video.
Driving by itself. There's no driver, Daddy. See?
That is nuts. It's pretty crazy. It's like there's a ghost at the steering wheel. Kind of feel like royalty being paraded around in this thing.
School zone.
Look at these guys. Looking over.
Are they?
No driver.
Go!
What?
This little Waymo thing is cruising.
Oh, it's a pretty sharp turn. He made it pretty smoothly. thank you? Do I say thank you?
We're here. We made it, and I didn't have to drive.
Okay, so I hope you enjoyed that fruitful self-driving experience for the Waymo self-driving car. Okay, but of course, back to the topic, right? Is IoT involved in such system? Okay, my answer to that, to be honest, I do not know 100%. Okay, I'm pretty sure that IoT is indirectly involved somehow. Okay, so when I mean indirectly involved, okay, it could possibly in this system, in this Waymo system, okay, data could be collected and sent to the cloud for analytics or processing purposes with the aim to improve the AV self-driving capabilities. Okay, but whether the IoT, right, is directly involved in the autonomous driving, okay, this I am pretty sure it has not been implemented yet. Okay, so at this stage, IoT is not directly involved in the autonomous driving. Okay, and I'll come to that later. Why is it so? Right, but before that, let me just share with you some of the ideal situation that IoT can help to shape, right, the entire AV industry. Of course, on a larger scale, of course, on a larger scale when there's more and more adoption of autonomous vehicles. Okay, so let's take, for example, we have an autonomous vehicle over here, and let's assume that other vehicles are already converted to an AV. Okay, and let's say this vehicle is connected, right, wirelessly connected to other vehicles. Okay, and this constitute V2V communications. Okay, and let's not stop there. Let's say we have the other smart devices on the roads being able to connect to the internet and connect directly, right, to this autonomous vehicle over here. Okay, so for example, we have the network infrastructure devices, okay, like the cellular towers, okay, and let's say we have the roadside devices like the traffic lights and or the traffic signs, okay, being connected to the AV. And last but not least, we may have the pedestrian personal devices also connected to the AV, and this allows the AV, right, to so-called sense right, the other devices presence all around it. This constitutes a V2X, vehicle to everything communication. Okay, so how does this V2X communication helps in the AV? Okay, let me illustrate in the next slide over here. Okay, so this V2X will help the AV to increase its driving capability, right? Or rather to increase the avoidance, the obstacle avoidance capability. Okay, but before I go into the explanation of the V2X, let's look at the norm, or rather the current systems. Okay, so the current AV system actually use, right, these various sensors. Okay, of course in different variations, right? So for example, like Tesla, Tesla prefer to use mostly cameras. Okay, but let's say a typical AV such as Waymo, right, use a variation of all these sensors. And if you look at all these sensors, the detection range is rather limited. Okay, let's take for example, if we have an AV over here, and it has ultrasonic sensors, or rather sonar sensors, right, which uses sound waves to detect obstacles. Okay, the range, right, of detection is very limited, up to only 4 meters. Okay, but of course, as technology advances, we have cameras in conjunction with machine vision algorithms. This help to extend the range up to 80 meters. Okay, but still 20 times better than the sonar, but still not good enough. Okay, but of course, as technology advances further, we have the radar or LiDAR sensors that uses radio waves or laser to detect obstacles. Okay, this can extend the detection range to up to 200 meters. Okay, this can be useful in some sense. However, if let's say the vehicle is moving pretty fast, right? Let's say for example 130 kilometer per hour, and the question is, can this range be safe enough, right? Or rather, give the car enough response time to brake and to avoid obstacles. Okay, so here comes the next question is that what if we have V2X communications, right, that allows us to extend the range of detection to much more than 200 meters. Okay, and allow me to illustrate further with the next slide how these V2X communications can help to avoid obstacles better. Right? Okay, let's take for example. Okay, so we have here is a comparison chart, right, or comparison figure, right, comparing AV with or without the V2X communications. Okay, if you look below, right, a chart over here, the red color dotted line, this is representing the AV without the V2X communications, and we have the green color dotted line over here. This is representing the AV with V2X communications. Okay, so let's take for example, if the AV is cruising along the lane here at 130 kilometer per hour, and let's say there's a traffic jam on the right side over here. Okay, and the AV without the V2X communication will continue to cruise until within sensor range, right? Within the physical sensor range. Let's assuming that it's over here. Okay, only over here it detects there's an obstacle in front and it will start to brake, right, from a speed of 130 kilometer per hour. Okay, if you ask me whether that's safe, I do not have a direct answer for you. Okay, but I'll say in comparison to the system, right, to the AV system with V2X communication, okay, it will be safer. Okay, so let me just showcase example here. Let's say again, the AV is cruising 130 kilometer per hour. And at this point, okay, due to the V2X communication, it is able to detect there's a traffic jam over here. Okay, and this can prompt the AV system to automatically decelerate at a lower speed. Okay, let's assume that it's 70 kilometer per hour, right, at a safer and lower speed. Okay, and it will continue cruising until it is the physical sensors is within range to detect the next obstacle, and then it can brake to a standstill just before the next obstacle over here. Okay, so in comparison, I'll say that the AV with the V2X communications is much safer, as increased the driving capability of the car by increasing the obstacle avoidance capability. But of course, the question is the current technology, right, such as 3G, 4G, good enough that we can implement such concept, such ideal concept, right, within the AV industry? Okay, of course, it is evident that the 3G and 4G networks are not robust enough in terms of connectivity. And of course, it is not fast enough, right, for the AV system to implement such concept. Okay, reason being, if such limitations were to occur, right, the roads will not be very safe. Okay, so of course, there's always a solution to every problem, and that is the 5G network, which I would like to discuss next. Okay, so what is 5G? Right, over here, I'll briefly explain. Okay, so in short, 5G is the next generation of mobile networks, or rather advanced version of the current 4G LTE networks. Okay, so it's designed to meet, or rather to support, right, mass IoT adoption. And reason being because, right, as our technology grows, as the amount of connected smart devices grows, okay, the current 4G or rather the current 3G, 4G networks are unable to support. Okay, we are already facing an overcrowding issue within the current spectrum. Okay, more to be discussed later on. Okay, but just take note, okay, as the amount of devices grow, okay, so be it personal devices, right now we have on average 3 smart devices per person. What if that is going to be increased to 7 as projected by some of the experts? Okay, and that can possibly increase, right, the necessary skill that we need that 5G can help to support. Okay, but the current technology, 3G, 4G, is already facing problems in supporting such mass adoption. Okay, so what are the summarized, what is the advantages of 5G? Okay, so number one, it gives a higher bandwidth gives a lower latency as well, and is able to connect many devices at the same time. Okay, so just a comparison, right? As compared to 4G, it can connect up to 100 times more devices than the 4G allows. Okay, this is pretty big difference, right? And of course, like to reiterate my point that the 5G networks is able to highly support mass IoT adoption. Okay, so this just a quantitative view, or rather quantitative comparison of the 5G performance versus 3G and 4G counterparts. Okay, so it's quite evident, and if compare in terms of three features, bandwidth, latency, and average speed, right? It's quite evident that the 5G performance exceed, right, the other two quite significantly. Okay, it performed a lot better, right? And some technologies that made 5G possible. Okay, so number one, millimeter waves. Okay, so as I mentioned just now, the current technology, 3G, 4G, and rather radio waves are being stuck within this mobile spectrum. Okay, 0 to 6 gigahertz. Okay, so the idea of millimeter waves is to expand to a new, right, mobile spectrum, or rather tapping into the higher frequency range. Okay, high frequency and smaller waves range over here. Okay, and this can help to solve the overcrowding issue, right, that the current networks are facing. Okay, however, this comes with a double-edged sword when we tap into this new mobile spectrum. Okay, and for those of you aware, if you use a higher frequency wave, okay, this can spell a problem because number one is unable to penetrate obstacles very well. Number two is unable to travel at a longer distance. Okay, of course, the solution to this problem can be solved by introducing a new technology known as the small cell network. Okay, so to explain this, let me first explain the current infrastructure that is done by the 3G or 4G. Okay, so the current infrastructure by the 4G or 3G, right, is being supported by various macro cellular towers. Okay, but however, if you switch that to 5G and if you adopt the millimeter waves, right, that will decrease the coverage of the network. Okay, so effectively, right, to solve this, we introduce small cell networks by spreading out the infrastructure. Okay, by introducing small cell devices where we place all over the place in order to cover the loopholes of the macro towers. Okay, of the macro cellular towers. Okay, so for example, we can place it at the lamps, or rather at the high-rise buildings, or even within our individual homes. Okay, and this helps to solve the limitations of using the millimeter waves. Okay, so to end off for my part, for the introduction, okay, in summary, 5G helps to support mass IoT adoption, right, because it is able to provide the necessary speed, low latency, and robust connectivity that is able to help us to expand to a new range of applications. Okay, so for example, as I mentioned just now, right, the autonomous vehicle application. Okay, and of course, mass smart homes adoption can be also achieved, right, with the 5G technology. Right, with that, I would like to end my introduction. I'd like to pass on the mic to Kok Leong to further discuss on the security components. Kok Leong, please.
Thank you, Dr. Nicholas. Hi, very good evening. My name is Kok Leong. I'm a lecturer and consultant with Institute of System Science. The main topics that I teach in ISS are related to cybersecurity, including the system, clouds, IoT, or security architecture. These are the three topics that I'll be addressing for today for security considerations to enhance IoT security. The first one is the softwareizations in 5G. What are the issues and what are the solutions? The second one is the constraints in the IoT and network space and what are the solutions? And lastly is the end-to-end security requirements in the IoT space and what are the solutions. First, I start with the softwareizations in 5G. I borrowed this image to illustrate the SDN and network function virtualizations in 5G. I'll explain the term later on. In these diagrams, we see on the left side, these are the end user environments whereby they send the data from the IoT device to the enterprise or the backend clouds. The data will travel along through the network. And in this network, in the space of 5G, this network utilizes the SDN and network function visualizations. So I'll explain this term. This is another image that illustrates the use of SDN and network function visualizations. So first is the network function visualizations. What is network function visualizations? Start from the idea of server visualizations. On the left side is an image of a hardware server. In the past, one server would have housed one's operating systems and respective applications. But it was realized that most of the time the hardware was underutilized. Therefore, the idea of extracting the hardware into a virtual machines. The advantage of doing this is that in one physical hardware, we then are able to house many copies of the software. It could be 10 or even 100 copies of software. So that is the beauty of server virtualizations. Now, by doing so, the network functions in the ecosystem remain the same as hardware. So although the physical machine has been extracted into a virtual machine in terms of software, the network device remain as physical machines. Therefore, the idea of network virtualizations. So this network device is now virtualized to become the software versions of the equivalent. Now, by doing that, we still need the hardware machines. So we have the server, the storage, and the basic switches. And importantly, the idea of network virtualization allows us to utilize general purpose servers instead of the expensive network equipment. This is one important value of doing this. This is another image of network virtualizations. So by virtualizing the network, we still need the physical server, storage, and switch, the commodity device. So that was the idea of network function visualizations. The next one is the software-defined networking. I'll do a quick briefing on this one. In the past, when we want to manage the network device, the administrator will have to log in to the individual device to configure the network switches or router, because the administrative functions of the device were housed within that machines. Then in the era of software-defined networking, that layer of software logics has been removed and spread out into controller layers. And as a result, only the data plane layer remain at the network device. This idea of separating the control functions away from the data functions is known as software-defined networking. The advantage of doing this is that the controller will have an overall view of what is happening in the network. For example, if the data path in one path is blocked, then the controller has the overview to redirect the traffic via another route. This is one advantage of doing software-defined networking. This is another image of illustrations. So the controllers is being removed from the switches over here. So with the software-defined networking and network function visualizations that allow us to create network slicing, which is the virtual network of various usage. In example here, a smartphone, autonomous vehicle, and IoT device. So with that, we have progressively softwareizations in the 5G. What does this mean to cybersecurity? It means that we have effectively expanded the attack surface of the telecommunication networks. CVE, the common vulnerabilities and exposure, is one count of tracking the number of vulnerabilities found in software. And in this trend, you can see that for the year 17 to 19, there has been a major increase in the software vulnerability found in this space. In other words, when 5G chose to adopt software-defined networking and network function visualizations, it has expanded into a software space, and that increased the cybersecurity risk in this telecommunication network. Now, recaps in 4G, when 4G decided to adopt a full-fledged IP-based infrastructures, it also increased the security issue compared to the previous generations. But nevertheless, as 4G adopt the IP-based infrastructures, there are also countermeasures introduced to address the risk factors. And this include EAP authentications, TLS, IPsec, and many other examples. So these are addressed by IT security. So back to softwareizations in 5Gs, there are also countermeasures, and these are some examples that I listed here. Isolations, redundancy, automations, defend in depth, zero trust network, or SAN top 20 hygiene factors such as patching. And these solutions are addressed in visualizations and cloud security. The second considerations over here is about the constraints behavior in the IoT and the network. I start with the block diagrams. In these block diagrams, on the left side is the network device, and the network device will send data to the application. This can be cloud or enterprise backend via a network. This network can be a short-range network or via a long-range network, or short-range to a gateway and then long-range to the applications. This long-range network can include the 5G. So this is the block diagrams. And I want to use this case study. Awful is quite dated, but nevertheless, it serves as a very interesting example to illustrate the constrained behavior of the IoT. In the year 2014, when Awful was starting this business, one issue they found was that the IoT gadgets that was in the bicycle tend to drain out the battery. And on the monthly basis, the administrator will have to go around nationwide to change the battery in the bicycle. So that was not a very neat operations. In the intervention solution, they have used padding to charge the battery in the bicycle. But the long-term solution was to solve the constraints behavior in the IoT device. And that constraint behavior was the battery. And at a point in time, the IoT device was using GPRS, and on the sidelines, they were working with the telco to introduce NB-IoT, narrowband IoT. The behavior of NB-IoT is that it has short messages, and also it will go to sleep modes whenever it is not in operation. This behavior of short messages and sleep modes help to retain the battery life cycles in the bicycle. And therefore, the constraints faced in this case is the battery, the power energy source. Now, in this picture, this is a pacemaker. What is the constraint in this pacemaker? The constraints is a power source. The power source in the pacemaker will have to last either 5 years or 10 years. So that we cannot expect the patient to go to the hospital every other month to have their battery in the pacemaker charged. So there is a constraint behavior in the battery of the pacemaker. In this example of autonomous vehicle, I borrowed the slides from Dr. Nicholas. What is a constraint? The constraints of this use case is in the latency. And we know that for cybersecurity, it is always known as an overhead. So given the constraints of the IoT device, then the solutions to add cybersecurity into IoT would not be the same as the way we do in enterprise security. I'll give an example. I use these slides. I give examples of Zigbee. Now, in a Zigbee setting, there are various security configurations. And in these examples, at the lowest level of security is no security. For example, none. So data encryptions can be turned off and integrity can be no. So the configuration options in Zigbee allow us to have no security. So it depends on the use case of the IoT device. So it may not allow the security overhead to be introduced into the equipment. In these examples, it is quite typical of clouds to utilize MQTT. MQTT utilize TLS to connect from device to the clouds. Now, what is the issue with TLS connections? The TLS is a connection protocol. In other words, when TLS is being used as a security mechanism to support MQTT, it will drain the power source of the IoT device. So for this application, it requires the IoT device to be constantly charged. And for devices that have constraint in energy source, then MQTT over TLS is not the solution. Then what is the answer? It could be DTLS, or it could be something else. For example, score. I will not illustrate further on this one, but these are some examples available in the market. So in other words, in the space of IoT, security basically inherits these constraints. So as we design or evaluate IoT device, we have to look at it from the perspective of these constraints. And the solutions is not as simple as those adopted in the enterprise security. The third considerations that I'd like to brief here is the end-to-end security in IoT. Ideally, we should have the security mechanism in every layers of the ecosystem. But because of the constraints, we'll have to be cautious so that we optimize the security solution. And one consideration is to achieve end-to-end security. First, what is the meaning of end-to-end security? I use this image to illustrate with the source on the left side and the destinations on the right side. End-to-end security means that as our data travel from source to destinations, there is no way that the data can be lost while in transit. So all the way here must be protected such that only the end can see the data that's sent by the source. So using the block diagram as in illustrations, if the IoT device is a source and the cloud is the end, then end-to-end security means that as the data travel from short range and then long range and all everywhere from to the 5G network to the backbones, so the data must be secure from one end to the other end. How do we do that in IoT space? We look at examples of payment system. How does payment system achieve end-to-end security? So on the left side, we have our smart cards. These smart cards have the data transported across the ecosystem. So the data can flow to many devices, network, and eventually the data will be landed in the banks. So end-to-end security means that only the end can see the data from the source. In other words, only the banks can see the data that is being sent from the source to achieve the end-to-end security. And the way the bank does this is that at the source side, the bank utilize smart cards. So this is a smart cards. Within the card, there is a microprocessor. This microprocessor is tamper resistant. In other words, if a hacker were to attempt to break the cards and steal the data will be zeroized, tamper resistant. At the bank sides will utilize the hardware secure modules. So likewise, at the highest level of security, if anyone were to try to break open the device, the data in the box will self-destruct. This is another illustration of hardware secure modules used by Google, so Google Clouds. So in other words, to achieve the end-to-end security, the acceptable solution in the market is from hardware to hardware, from a microcontroller to a hardware secure module. So in the banking examples, we have smart cards which contain the microprocessor, and then the data will flow all the way to the hardware secure modules in the banks. So data exists inside hardware and then gets seen by another hardware. The security in the data transport is end-to-end. How do we do this in the IoT space? This is one possible solution in the IoT space. In this example, there is another processor, hardware secure module. This is another picture from another view. So in this circuit box, there will be already a microprocessor. Then this additional circuit box serves as the hardware secure modules. Now, what is the issue with this design? Earlier parts, we see that IoT is not the same as enterprise security. IoT behavior at the extreme end has a constrained behavior. So for application that has such behavior, then the inclusion of another microprocessor will drain the battery. So this may not be the solution for constrained device. Then what is the solutions, or what is the ideal solution for the IoT space? The answer is in trusted executions environments. This has been adopted in the mobile phone space and has been made available to the IoT space since the year 2018. So let me do a brief on this technology. Trusted execution environments is a standard introduced by the consortium. What it does is that instead of using two microprocessors computer chip to fulfill a normal space and a secure space, TEE placed these two spaces within the same microcomputer chip. So in this microcomputer chip, there is a partition or isolations. And with these isolations, on the left side is the normal rich execution environments, and on the right side is a secure rich execution environments. I'll give an illustration later on. Example of this technology is by ARM, known as trust zone technology. I used the image to illustrate this technology. On the left side, we see that there are two processors to achieve the one secure zone and one unsecure zone, two processors. And these two processors will definitely drain the battery faster. So the ideal solution is to have one processor on the right side, one processor, but there are two partitions. One partition is the trusted secure zone, and the other partition is a non-trusted view. And this is achieved within single processor. So that's the beauty of this technology, single processor. And this will overcome the constraints of energy source. In these examples, Apple Watch has been using the technologies, or Apple phones have been using this. That's why the Apple phone are getting smaller and smaller since the, I think, version 6. Now, the example use of this technology is Netflix. In these examples, for when Netflix stream down the video source to the devices, Netflix will detect whether the source is a mobile phone or a browser. If the requested source is a browser, Netflix will stream down a low resolution video. And if the source requester is a mobile phone, then Netflix will stream down a high resolution video, but in encrypted format. And the video was streamed down to the phone in the encrypted format and passed to the rich executions environments. And this is where we download the Netflix applications. But the applications itself cannot see the video because the video is encrypted. Then this video will then be passed over to the trusted execution environments where either Apple's or Android will preload Netflix key into the trusted area. Then the Netflix trusted application will have the key to decrypt the video source and present to the display. So in this way, Netflix is confident that the high resolution video is protected. This is one use case of trusted execution environments and has been used in phone for a couple of years. Another example is the Samsung Pay. I'll not go through the detail. Now, what happened is that the technology of trust zones that has been used by Apple phones for many years is utilizing the processor family known as Cortex-A. And in the design of ARM, there are 3 families series. So there's a A series, R series, and M series. Now, M series is the one that is of interest to us in the space of IoT design or evaluations. So 3 families series of the microprocessor architecture design. So again, in the M series, so we have A series for the phone, R series, and the M series. The M series is the one that is used for lowest power and lowest cost devices. And this M series is for IoT device. How do we go about evaluating IoT products or design IoT product with this ARM's architecture design? So we look at the ARM architecture series. In the M families, there are a few models. So over here we have the M35P, M33, and M23. Now the trust zone feature is only available in the ARM version 8-M. So over here, ARM version 8-M. So if you look at if we are evaluating the IoT device and we look at the technical specifications, we need to look out for these keywords. So it should be Cortex M35P, M33, or M23 to look out for whether do they have the trust zone features. Now this is based on the ARM architecture design. The ARM architecture designs are being licensed to 20 over chip manufacturers. One example is the microchip. So microchip will turn this design into products, into microcomputer chip products. And in these examples, the M23 series is known as SAM-L10 or SAM-L11. And when we design or evaluate the IoT device, we need to look out for these keywords. For example, SAM-L11 has the trust zone features, and the products SAM-L10 do not have the trust zone feature. What this means is trust zone is an optional feature. So if we are evaluating things, we need to make sure that the microcomputer chip utilized by the IoT device has a trust zone feature. But having said that, it doesn't mean that the IoT device has utilized the trust zone's hardware features. The other aspect to look at is also the software. Does the software of the IoT device utilize the trust zone feature? And this is a question mark, and it's a question mark that we should pose to the developers. So with that, this is the last slide for the third considerations. I shall end my sessions.
Thank you, Dr. Ho and Mr. Ng. So our speakers will now answer some questions posted on the Q&A panel. Currently, there are already a few. But please feel free to continue submitting any of the questions that you may have directly to either Dr. Ho or Mr. Ng or both of them.
Okay, I guess I'll start first. Let's give Mr. Ng some time to rest a bit after his talk. Okay. Okay, so we got a question here. So how exactly does the V2X technology helps to determine the positions of the obstacles? For example, those of other vehicles on the road. Okay, so I apologize that because in the view of I mean, in interest of time, I did not explain that very detailed. Okay, but since we are in Q&A, I can spend a little bit more time to explain that. Okay, so as to how exactly does this works? Okay, so if let's say we have the V2X communication and we have this AV connected to every other device on the road. Okay, so that is V2X communication, right? So let's say it's connected to this bus, right? And of course, this bus has to be an autonomous type, okay, or rather a smart vehicle, okay? And let's say it's connected to all these lampposts at the side and connected to all these vehicles on the road, okay? So how does this work? Let's say all these vehicles as well as the lampposts, okay? All you need to do is install a location sensor such as a GPS. Okay, so with let's assume that all these vehicles and the lampposts are installed with a GPS. Okay, that could possibly tell this AV, right, where's their locations. Okay, so we've given their location, okay, and also given the AV will have their own location sensor, okay, or rather the GPS sensor, okay, is able to intercommunicate. Okay, let's say it's all connected via network okay, is able to tell the location of all these devices or other vehicles on the roads, okay, by its location data. Okay, so this exactly how it's able to tell, okay, where exactly all these obstacles are on the road. Okay, I hope that clarifies things, right?
Okay, let me address the second questions on the list. This question is about most of the IoT devices do not have any security update at all. So especially those no brands device, should there be a law or standards to at least make as mandatory? Now in Singapore, we are fortunate to have CSA who has introduced the labeling scheme. At this point in time, the labeling scheme is voluntary, and I think there are only the home-based router is mandatory. I think so. Need to recall on this. So I think this is a very good start. In general, the report is saying that 80% of the IoT devices in the market are not secure. And why do you think this is the reasons? So if you talk to the suppliers in the markets, I'm sure you have a lot of chance to talk to them. One of the reasons why the developers are not building security into their products is that the customers are not asking. And that is a surprise answer because they are waiting for you to ask. And it means that you must be willing to pay for the extra security features. If not, then to them, adding security features into the products is additional resource, additional overheads, and add complexity and cost to the development cycle. So I think the labeling scheme is a very good starting point. Aside to that, as the consumer, especially those enterprise consumer, I think we should start asking for a more secure device. And in Singapore, we are fortunate to have IMDA who introduced the IoT security guidelines. To this date, there's no standard in the world yet. So we can look towards the IMDA IoT security guidelines as we purchase IoT device in the enterprise. I hope it answered the questions.
Okay, I'll take this another question. Okay, from okay, so the question is, are there any measures we can ensure higher availability for critical IoT applications such as autonomous vehicles in the 5G networks? Okay, so the answer there to this question, I'll say it's rather quite gray. Okay, but I'll just say from a personal point of view, okay, which is I don't think there should be measures to ensure a high adoption of critical IoT applications. I mean, just a personal view, I believe that due to market forces, okay, where people or rather the industry see where 5G can be very useful in their organizations, that's where they'll start to automatically apply or rather implement the critical applications. Okay, so take for example, okay, maybe not autonomous vehicles, or maybe take example like the gaming industry. Okay, like VR, AR. Okay, so the gaming industry like AR or VR, right? Okay, one of the problem that they are facing is the real time user experience. Okay, because given the video requirements that's required from all these technologies, okay, the current networks is unable to support. Okay, but of course, automatically, let's say we have 5G networks, industry players will come to see value in it, and they will start acting on it, right? When I mean acting on it, start planning as well as to implement, right, to integrate the 5G networks. Okay, so I hope that answers your question. Of course, as I mentioned, or I reiterate myself, this is quite gray, and this is just a personal opinion. All right.
Okay, there's questions about IIoT, industrial IoT device. The question is, a lot of IoT does not have the level of security required to protect against hacking, such as the CCTV. How can this be overcome? Yes, it's true that as a report is saying that 80% of the IoT devices in the market are not secure. So as a buyer, we need to be cautious and be aware. The labeling scheme is still not mature, so we do need to buy enterprise grade products, commercial grade products. Especially if you are the enterprise, we should go for enterprise grade products. That will give us some level of protections.
Okay, I will answer this particular question, also known as an FAQ. Okay. So the question goes like this: does 5G pose any health risks? Right, because it's using higher frequencies, as mentioned in my talk. Okay, so to answer that, I prepare a slide for this because this is as an FAQ. Okay, all right. Okay, so to answer that question, all right, there's a lot of myth surrounding this surrounding a 5G waves that is very harmful, and there's even rumors spreading around. If you recall last year, there's even rumors spreading around saying that the 5G technology causes the COVID. Okay, of course, I leave it to you who you want to believe. Okay, but my back to the topic, whether the 5G waves in general is harmful to us. Okay, so the 5G waves are within the category of non-ionizing radiation. Okay, so radiation, all these waves can be split in two main categories. Okay, if you look at this chart, the right side, okay, the rightmost side, these are all the ionizing radiation. Okay, so in short, all right, they are your very harmful waves. Okay, that is not good for the body. So be it X-ray or gamma rays. Okay, this is definitely no good if you're exposed to it. Okay, even ultraviolet waves. Okay, so all these are not good. Okay, but if you talk about your 5G waves, even though when you increase to a higher frequency, right, it does not increase to the extent that is within this category. Okay, it's still not within the ionizing radiation category, even though it is increased. All right, so if you remember, okay, by regulations, right, for 5G waves will be only up to 100 gigahertz. Okay, will be only to 100 gigahertz. That means 10 to the power of 11. So 10 to the power 11 is within this range, right? This, right, by standards is actually a very safe range, right? So it will not harm our body. Okay, and of course, if you ask me whether for the long term it will harm our body, okay, my answer to you is as good as your current phones, right? Whether it put near you all the time, whether it harm your body, right? That I leave it to the medical expert to answer you. Okay, but let's talk about, right, whether it will harm you directly. Okay, the answer is no. Okay, it does not belong to the harmful section. Okay, I hope that clarifies things.
Okay, the next question is about privacy and safety concern. The question goes this way. With the sensor and wearables, how can we make sure our privacy is protected? Should there be a law, etc., etc.? In Singapore, we are fortunate to have PDPA, and also there are, even for Europe, GDPR also have impact on our corporations here. So it is true that the credential that we have, passwords, privacy informations housed in those database are being hacked. So one good practice is to turn on two-factor authentications if the service that you utilize have that features. And if not, then we should attempt to use different passwords. So in case the password is compromised, at least it will not be publicized to harm other account that we have. Okay.
Okay, I'll answer this question regarding sustainability. I find it quite interesting. Okay, so the question goes like this: relating to our emphasis on sustainability, what is the expected durability or lifespan of IoT devices? Okay, again, this is a very great area, a lot to be discussed, a lot to debate about. Okay, but again, I'll give my personal view. Okay, so in terms of sustainability, I mean, my point is the government can only do this much. Ultimately, a lot of work, right? Whether the devices are can you want to be made sustainable or not, depends a lot on the industry players, right? So the be it the manufacturers or the company that is selling all these IoT devices. Okay, so to answer directly the question, what is the expected durability or lifespan? There's no direct answer to this. Okay, because this really ultimately depends, right, on the company that's producing the IoT devices. Okay, so let me give you an example, right? So take for example, the smart tracker that's given by the government. Yes, I can't remember exactly when, but a few years back, it's big hoo-ha. Even me myself, I went to collect. Okay, but I find it good in a way. Of course, there's intangible value in a way. It kickstart a lot of people to start exercising and all that. Okay, but when I look back, right now, my tracker has been already spoiled. Okay, and such a short time span. Okay, so back then I'm thinking, if this has been issued out to so many people, I believe most of the smart trackers given out by the government has already been spoiled. Okay, but of course, there's, as I mentioned, there's still intangible value, which is it does give people it does kickstart a lot of people to start exercising, even me myself. Okay, but of course, yeah, definitely, like on this point of view, if let's say the device, right, were to expire so fast, okay, then the organization or the company that is producing the IoT device have to consider, right, whether the parts can be recycled, right, whether the parts can be reused, etc. Okay, of course, this is just based on my personal opinion, right? Of course, if you ask me, I would advise every industrial players, right, to try to extend the durability or the lifespan of the IoT device so that you do not have so much carbon footprint. Okay, and of course, just disclaimer, not marketing here, right? But I'll say Apple products are pretty fit into this category. Their products are very durable, and even be their watch or phones, right, can last very long. I'm not sure whether their focus is on the sustainability, right? But it could be focused on the quality of the product, but the sustainability come secondary. Okay, so I hope that answered the question. Thanks.
Okay, there's this questions. It go this way. Can you please touch base on the end-to-end security best practices and trend in smart city and smart metering industry? I have not come across any utilizations of this end-to-end security in smart cities and smart metering yet. If there's any, I do welcome that you let me know. So in the use of the trust zones, even within the mobile phone, the usage has been very limited. So the example that I give on the Netflix and the payments, the other one is the digital rights management as well. So far the use case has been quite limited. That is for the mobile industry. So let alone about the IoT industry. So I think we are still at a very early stage of these developments. The first thing that we should be doing is to make this aware to the general public, so that as consumer, whether you're from home or enterprise, when you purchase a device, be aware that such technology are available. And we should start asking the developers, why are you not using it? Why are you not keeping your keys in the trust zones of the IoT device? So we should start asking such question so that the manufacturer will start developing a more secure device. Okay.
Okay, so this comes from one of the question. Okay, I bought many IoT devices installed in my home. Are there any concerns? Okay, so I'm not sure whether what specific concerns are you referring to. Okay, if you are referring to health, I would say you're safe. Okay, if not, most of us will experience harmful exposure already. Okay, which is not the case, right? So I think an average home, a lot of us have smart devices being connected. Okay, but if you talk about concerns pertaining to cost, okay, I mean that I cannot answer for you, but I'll just say at this point, right, most of the smart home IoT devices are still not economical enough, okay, to have a mass adoption. Okay, even if you talk about the cheapest one in the market, okay, not very cheapest, one of the cheapest in the market are the Mi products, right? They have a range of smart IoT devices that allow you to install at home. So be it smart lighting, smart cameras, etc. Okay, they have a range of it. You can even buy in one set. Okay, it's relatively reasonable. Okay, but my perspective is not cheap enough, right, for average earning income person to be accepted. I mean, to be a receptive of such systems. Okay, so I still think that we do have a lot of barriers whether we can have this mass IoT adoption. Okay, but I believe in the future, eventually we'll reach there. Okay, when technology advance and all these IoT devices, and of course the installation of the IoT system will be more affordable, right? So I believe we'll reach there someday.
I'd like to add on to that. So one of the concern is that mostly your device would have utilized the IP address, and the major concern is that whether the device allow software updates. So the inability for software update to the device is one of the major security concern that could happen. So unpatched software, especially those devices that have public IP address, are easy targets for the hacker to penetrate and create havoc in your home, especially for those items such as CCTV. So be very cautious on that. CCTV, check the brands and whether do they allow software updates.
Okay, there's this question. Okay, 5G networks more robust than 4G networks in terms of connectivity and availability. Okay, so to answer that, in theory, yes, it is more robust. Okay, 5G networks are more robust. Okay, in terms of these two features, right? But what has been proven so far, okay, in terms of connectivity, definitely it is more robust. Okay, whereas in the aspect of availability, that has not been tested on a very large scale. Okay, so I cannot answer. I cannot be 100% certain that it will be more robust in terms of availability. Okay, because right now a lot of the rollouts is in trials. Okay, especially in Singapore, right? Even if you talk about in China or in the US, okay, in other countries, it's still going out in phases, and it has not reached that large scale, right? That mass IoT adoption, okay, that we ideally want to reach. Okay, so if that whether is more robust than 4G networks, right, in terms of availability, I cannot answer, or rather I cannot be 100% sure. Okay, so I hope it answered your question.
Okay, there's the questions about the standards. Say, are there any international IoT security standards, example, aligned with the US First Forums. As of today, there are many guidelines, not many, but a few guidelines. There is not yet a standards. We can look toward US for the standards. The Trump signed the Cyber IoT Act. We look towards that to create international standards for IoT. Yeah, hopefully that happens. So there's no standard today. Okay, there's a questions about as a general 5G user, what are the security practices required? So as a user, so let's say we use mobile phone and connect to 5G. As a user, we should always ensure that we patch the phones. So as long as software exists, software will have vulnerability discovered, and then it is the responsibilities of the supplier to ensure that patches are available. So as a user, we should always up to date ourselves and ensure that the software in a phone is constantly being patched. There's a questions on similar standards, ISO BS 7799 and these are frameworks. These are not the standards for IoT. The NIST also provides guidelines on IoT. So as 5G adopts the software network function visualizations and software-defined networking, so as an enterprise user, we could look toward them being certified with the ISO 27000 series and other internet frameworks, cloud frameworks like the benchmark like SOC. So as a buyer, enterprise buyer, you can look towards them having their platform certified.
Okay, I'll take the last question. Okay, so we have interesting question. How realistic is a regional blackout scenario in a V2X world? Okay, what are the major vulnerabilities or risks in the near term, especially for smart city applications? Okay, so I think what you may be implying, okay, it could be what if there's a blackout scenario, let's say all the smart devices are shut down because there's no electricity. Okay, so whether this has implications, let's say for example on the autonomous vehicles on the roads. Okay, the answer to that, yes. Okay, definitely this will be a very major risk. Okay, but of course, certain things that there are contingencies. Okay, so take for example, autonomous vehicles, right? Let's say there's no, and if let's assuming that this V2X ideal concept is being adopted, and let's say there's a blackout as what you suggest, okay, and the V2X communications will definitely shut down. Okay, but then the question next is, can the autonomous vehicle function by itself even without the V2X communication? The answer to that is yes. Okay, because right, as I mentioned just now, the autonomous vehicles does not solely function just based on V2X technologies. Okay, they also have other technologies in place. For example, distance sensors like radar, lidar, ultrasonic sensors. Okay, and also the camera. Okay, for it to still function without the IoT capability, right? Such as the V2X communications. Okay, and even in the, let's say a blackout scenario, let's say there's no lights, whether the vehicles can still function, the answer to that is yes. Okay, so I will share with people that how the autonomous vehicle drive is how we humans drive. Okay, so if let's say the whole place is very dark, all the autonomous vehicle need to do is to on the headlight. Okay, just a simple solution to such a problem, and then the camera can function. Okay, so I hope that answers your question.
Okay, thank you, Dr. Ho and Mr. Ng, for sharing your insights and expertise on this particular topic for tonight. So a big thank you to everyone for joining us tonight and for participating for Tech Talk Online, organized by NUS Alumni Relations. So do stay tuned to our Alumni website and social media channels for more upcoming events. And we will be closing this webinar in 5 minutes. So once again, thank you for your support and good night.